this problem, side AB of an equilateral triangle lying in the xy plane is 3i. 3 units parallel to the x-axis, right? AB, 3 units parallel to the x-axis. AB is 3i. Which of the following can represent the side CB given that ABC is equilateral? That means the length of each side is 3 units, right? So the third vertex could either be above AB or could be below AB. There are two possibilities, right? So suppose C lies somewhere here. Suppose C lies somewhere here. Then this is 3 units, right? The vector CB is like this, and it could be resolved. Realize that this is 60 degrees. So this is also 60 degrees. So it could be, this 3 could be resolved as 3 cos 60 degrees, means 3 by 2. And 3 sine 60 degrees, which is 3 root 3 by 2. 3 cos 60 degrees and 3 sine 60 degrees. Right? So the vector CB, the vector representation of CB, one of the possibilities is 3 by 2 I cap minus 3 root 3 by 2 j cap. That's one possibility for CB. That's one possibility for CB. Isn't it? The second prospect of C being here, that's another possibility. C could also be below AB. Again giving you an equilateral triangle, 3 units of side, right? This would be 3 units this way. This is 60 degrees. So again giving me 3 by 2, 3 cos 60 degrees this way and 3 sine 60 degrees this way. So then the vector CB is going to be 3 by 2 I cap plus 3 root 3 by 2 j cap. These are the two possibilities for the vector CB, the side CB, the vector representation of the side CB. Clear? We are talking of an expression A dot B cross I cap I plus A dot B cross J cap J cap plus A dot B cross K cap K cap. We want to be able to simplify this expression. We want to be able to simplify this expression, right? Now, do you realize that the dots and the crosses are interchangeable? So, essentially, if I talk of, say, A dot B cross I cap, right? This could have been written as A cross B dot I cap. Yes or no? Right? Which is what? Which is the component of A cross B in the x direction? Which is component of A cross B in the x direction? Right? Yes or no? Adip? So A dot B cross I, this part is component of A cross B in the x direction into I cap. Similarly, this will be component of A cross B in the j direction, j cap. This will be the component of A cross B in the z direction, k cap. So that's simply going to be the vector A cross B, isn't it? The vector A cross B is its component in the x direction, I cap, plus its component in the y direction, j cap, plus its component in the z direction, K cap, yes or no? See, this actually is component of A cross B. Say, component of A cross B in the x direction. Loosely speaking, this is a number. This is component of A cross B in the x direction, I cap, component of A cross B in the y direction, J cap, plus component of A cross B in the z direction, K cap, must be the vector A cross B. Right? So this must be simply A cross B. Brother. ABCD is a quadrilateral. ABCD is a quadrilateral. Problem 3. E is the point of intersection of the lines joining the midpoints of opposite sides. Say midpoint of this side and midpoint of this side. Say the midpoint of this side is P, the midpoint of this side is Q. The midpoint of this side, let's say, is R, the midpoint of this side is, say, S. Right? And what's O? O is the intersection of PQ and RS. O is the intersection of PQ and RS. That's O. And if oh sorry, E is the point of intersection. E is the point of intersection of PQ and RS. Right? O is any point. O is any point. And if OA plus OB plus OC plus OD is X times OE, we want to be able to find X. We want to be able to find X. Hey, if O is any point, can we not choose O as the origin? If O is any point, then O could be chosen as the origin, right? So then, what would OA be? OA would be the position vector of A. OA would be the position vector of A. Similarly, OB will be the position vector of B, OC will be the position vector of C, and OC will be the position, and OD will be the position vector of D. And similarly, OE will be the position vector of E, say. Can I say all of this? Right? So, position vector of A, position vector of B, position vector of C, position vector of D, and this is the position vector of E. Now, what's the position vector of B? Midpoint of AD, that means A plus D by 2. What's the position vector of Q? B plus C by 2. What's the position vector of R? A plus B by 2. Position vector of S, midpoint, C plus D by 2. Now, do you realize that the midpoint of PQ, just observe, the midpoint of PQ would be P plus Q by 2, isn't it? The midpoint of PQ will have position vector P plus Q by 2. Right? And P plus Q by 2 means it will be A plus B plus C plus D by 4. Right? Which is A plus B plus C plus D by 4 is going to be the midpoint of PQ. नहीं क्या बोलो क्या प्रॉब्लम है? And midpoint of RS, observe, will have the position vector R plus S by 2. the position vector of this point is going to be r plus s by 2, and again r plus s is a plus b plus c plus d by 4 is what it's going to become then. So that's a plus b plus c plus d by 4. Which means the midpoint of PQ is the same as midpoint of RS, and therefore both must intersect at their respective midpoints. That means E must be this point, a plus b plus c plus d by 4, which lies on PQ as well as RS and is respectively their midpoints. They have a common midpoint. Their point of intersection therefore must be their midpoint. They intersect at only one point. On RS there is a point with this as the position vector. On PQ there is a point with this as the position vector, which is the same point. That means PQ and RS must intersect at this point. That means this point must be E. The position vector of E must therefore be a plus b plus c plus d by 4, must be E, right? So can I then not say that E is a plus b plus c plus d by 4? Or we have a plus b plus c plus d is 4 times C. This is OA, this is OB, this is OC, this is OD, and this is OE. So this X must be 4. X must be 4. Those of you who missed the class on Friday, I have uploaded that class on LAN. It's on F drive. The folder titled is Friday 25/9/2015 induction. So it's there for the consumption of those who missed the class. So please watch that. If you've missed that class, or if you came for that class and you were not very comfortable, you can watch that again. I have uploaded it. In case you do not know, you're not able to locate it, seek Rudroda's help, he'll tell you. Clear? There is a, in problem 4, there is a tetrahedron O. One of the vertices is the origin. One vertex is A, 1, 2, 1. One vertex is B, which is 2, 1, 3. One vertex is C, which is minus 1, 1, 2. We want to find the angle between the faces OAB and ABC. OAB and ABC, the three faces. I want to find the angle between the, just to bring to your notice the tetrahedron once again. If this was a plane ABC and there was a point O outside this plane, then this would be the tetrahedron OABC, etc. This would be the tetrahedron, right? Now, to find the angle between the faces OAB and ABC, it would suffice if I found the angle between their normals. Yes or no? Right? Now, can I say that a normal to OAB, a normal to OAB must be like a OA cross OB must be a certain normal to OAB? OA cross OB will be normal to OAB? OA cross OB means this determinant will turn out to be I, J, K. The vector OA would be actually the position vector of A, I plus 2J plus 1, 2, 1. OB, 2, 1, 3. That'll be a normal to OAB. So you can simplify this I into this, minus J into this, plus K into this, etc. So you have knowledge of a normal to one face OAB, right? Normal to face ABC could be, let's say, AB cross AC. What's the vector AB? Position vector of B minus position vector of A, isn't it? Position vector, that means 2 minus 1 I cap plus 1 minus 2, that means minus J cap, plus 3 minus 1, which is 2 K cap. That's AB cross AC. AC. So minus 1 minus 2 I cap, 1 minus 2, so minus j cap, plus 2 minus 1 plus k cap. That's the vector AC, final position minus initial position, and this you could simplify as ijk, 1 minus 1 2 minus 2 minus 1 1, right? The angle between these two normals will give you the angle between the two faces as well. Angle between the normals to the two faces will be the angle between the two faces. That means, how do you find that? So NOAB dot NABC, you can find, right, this dot product. You can find the dot product. That will be mod NOAB into mod NABC into cos theta. Theta would be the angle between the two normals. Mod n you can find, mod ABC you can find, cos theta is what you need, and the dot product you can find from these two final expressions. So you can find cos theta, and therefore you would get theta equal to, let's say, some cos inverse something. Okay. The lines, problem 5. There is a line R equal to I minus j plus lambda 2i plus k, and there is another line, position vector on this line is, of any point on this line, is 2i minus j plus mu into I plus j plus k. Is this line. Hey, I could have used lambda here as well, does not matter, because I vary lambda to get position vectors of different points. So it's not that they have the same lambdas. I plus j minus k, right? Now, if you remember, if there is a line R is a plus lambda b, let's say a1 plus lambda b1 is this line, right? And there is another line which is a2 plus lambda b2. Then this line will be parallel to b1, this line will be parallel to b2. So if b1 and b2 are not parallel, then the lines are not parallel. In this case, these are b1 and b2, are they parallel? No. So the two lines for sure are not parallel, they are not parallel, right? And again, if you remember, the condition for the two lines to intersect is what? Please tell me the condition for the two lines to intersect. a2 minus a1 dot b1 cross b2 must be 0. That's a condition for the two lines to intersect. Right? That means scalar triple product a2 minus a1. Have I done this? b1 b2 must be 0. What is a2 minus a1? Say this was a2, this was a1. So in this case, a2 minus a1 is I, is simply I, a2 minus a1, and say b1 is 2i plus k, and b2 is I plus j minus k. That means scalar triple product a2 minus a1 b1 b2 is given by a determinant. What determinant? It will be 1 0 0 2 0 1 1 1 minus 1. That's the determinant. If this is 0, then the two lines intersect. If this is not 0, the two lines don't intersect. Is it 0? Okay, these two terms will give me 0. This is not giving me 0. So it's simply giving me minus 1. It's simply giving me minus 1. So it's not 0. Therefore, the two lines don't intersect. Don't intersect. The shortest distance between the two lines is not 0. How do you obtain the shortest distance between them? Divide by mod b1 cross b2. This length. R is a unit vector. R is a unit vector satisfying R cross A equal to B. Satisfying R cross A equal to B. Mod R is 1. And it's given that mod A is root 3, mod B is root 2. We want to be able to solve for R. We want to be able to solve for R. Now, let me do A cross R cross A. Let me do A cross on both sides. This is vector triple product, which is like A dot A into R minus A dot R into A is A cross B, right? A dot A into R minus A dot R into A is A cross B. Now, A dot A is mod A squared. Mod A squared means 3. So that makes it 3R equals A dot R into A plus A cross B. Right? Now, to solve for R, I need A dot R. I need the value of A dot R. Come down to this. That means I need mod A into mod R into cos theta. Come down to the mother equation. The mother equation tells me mod of R cross A is mod of B. Mod of R cross A means mod of R into mod of A into sine theta is mod of B. And mod of R is 1. Why? It's given, unit vector, right? So that gives me sine theta equal to mod B divided by mod A. Mod B divided, that means root of 2 by 3. Cos theta therefore would be plus minus 1 by root 3. Root plus minus root 1 minus sine square theta. So cos theta therefore would be plus minus 1 by root 3. Okay. Now what is A dot R? A dot R is going to be mod A into mod R, which is 1, into cos theta. And mod A is root 3 and cos theta is plus minus 1 by root 3. So this can be plus 1 or minus 1. So A dot R could be plus 1 or minus 1, right? Right? So all that you need to do is, this is like plus minus A. A dot R could be plus 1 or minus 1, plus minus A plus A cross B. So that gives me R equal to 1/3 of plus minus A plus A cross B. Two possibilities. There could be a plus or there could be a minus for the vector R. Let's look at problem 7. So this gives me, problem 6 gives me A as an option and B as an, and C as an option. A and C are two appropriate options. There are three distinct vectors, X, which is AI plus BJ plus CK, Y, which is BI plus CJ plus AK, Z, which is CI plus AJ plus BK. These are three distinct vectors and they are coplanar. They are coplanar. Coplanar means what? When would three vectors? When their scalar triple product is 0. For them to be coplanar, their scalar triple product must be 0. Right? Or ABC, BCA, CAB must necessarily be 0. This is a regular determinant. This is like a cube plus b cube plus c cube minus 3abc is 0. Do you know how to factorize this? You have not seen this identity? This is factorizable as a plus b plus c into a square plus b square plus c squared minus ab minus bc minus ca. That's 0. Right? Now, either this will be 0 or this will be 0. Either this will be 0 or this will be 0. Now, realize that this is half of a minus b whole squared plus b minus c whole squared plus c minus a whole squared. Right? This one, half of a minus b whole squared plus b minus c whole squared plus c minus a whole squared. Now, this cannot be 0, because if this were to be 0, a must be b must be c, because they are real numbers. So, this factor cannot be 0. Otherwise, it will lead to all of them 0. That means a equal to b equal to c. If this were to be 0, then this will be 0, this will be 0, this will be 0. Sum of 3 non-negative numbers causing a to be b to be equal to c. Equal to c. Right? So, this can't be 0. This must be 0. A plus b plus c must be 0. Now, once we have this, let's look at what is required. X dot y plus y dot z plus z dot x. So far so good, right? The expression x dot y plus y dot z plus z dot x. X dot y, for example, will be ab plus bc plus ca. Right? Similarly, y dot c, y dot z would be bc plus ac plus ab. Similarly, z dot x will also be ab plus bc plus ca. Yes or no? So, this would actually be 3 times ab plus bc plus ca. Right? Yes or no? Now, we want to find the maximum possible value of this. We want to find the maximum value of this given that a plus b plus c is 0. Now, if a plus b plus c is 0, then a plus b plus c, a square plus b square plus c squared plus twice ab plus bc plus ca is 0, squaring both sides. Right? That means ab plus bc plus ca is minus half a squared plus b squared plus c squared, which is always less than 0, because a, b, c are real numbers. Therefore, this will also be always less than 0. It could be brought as close to 0 as you like, but less than 0 always. So, the maximum value of this will be 0. Theoretically, the maximum value of this will be 0. I could make it like a value minus 0.0005,000 zeros and then a 1. So, I could bring it at as close to 0 as I like, but so that's the limiting value of this. Limiting maximum value of this is 0. So, the limiting maximum value of this expression is 0. Right? Can I wipe this off? Unit vector vector giving direction of a ray incident on a plane mirror in the xy plane. There is a plane mirror in the xy plane, lying in the xy plane. And there is a incident ray. There is an incident ray whose vector description is, a unit vector along the incident ray is like a Li cap plus Li cap plus Mj cap plus Nk cap is a unit vector along the incident ray. That's given. A unit vector along the reflected direction. This is the reflected ray. We want to find a unit vector along the reflected direction. Hey, tell me this. This Li plus Mj plus Nk is along this direction, right? It could be resolved in a component along the parallel to, this will be a component parallel to the xy plane. This will be a component in the z direction. Because if this is the xy plane, then this must be the z direction. Normal to the plane must be the z direction, isn't it? If this is the xy plane, then the normal to the mirror must be the z direction, right? Therefore, realize that its component in the z direction is nk. So this must be nk. And this is the component parallel to the xy plane, and this therefore must be Li plus Mj. Yes or no? Right now? Now, when it gets reflected, do you realize that the component parallel to the mirror will remain the same? The component parallel to the xy plane will continue to be Li plus Mj plus Nk will be a Li plus Mj will be the component parallel to the mirror, parallel to the xy plane. However, in the z direction, instead of this being Nk, you will have a vector like this, which would be minus Nk in the z direction. Only this component will get reversed. Therefore, this vector, a unit vector in this direction, is going to be Li plus Mj minus Nk, right? So a vector in this direction is, unit vector is going to be along the reflected ray, that is Mj minus Nk. What do you say? Problem 9. We have a vector A given by 2i cap plus j cap minus k cap, and a vector B which is given by 3i cap minus 5j cap plus k cap. These are two constant vectors. And we have a line R cross A is B cross A, and another line R cross B is A cross B. Let's be sure that these represent lines. Why do you think this represents a line? If I do this minus this equal to 0, then this gives me like a R minus B cross A equal to 0, right? That means R minus B must be parallel to A. R minus B must be parallel to A. If the cross product is 0, that means R minus B must be lambda times A. Yes or no? So this line is like R minus B equal to lambda times A. Therefore, this line is R equal to B plus lambda A. That's line 1. This is a line passing through a fixed point with position vector B and parallel to the vector A, right? Similarly, this could be rewritten as R minus A cross B equal to 0. That means R minus A will be parallel to B. That means R minus A could be written as some lambda B. That means the equation of this line is R equal to A plus lambda B. is the equation of this line. This is a line passing through a point with position vector A and parallel to the vector B. This line is therefore parallel to A, this line is parallel to B. Angle between the two lines is the same as angle between A and B. So all that you need to do is A is given, so A dot B is mod A mod B cos theta. A dot B you can find 6 minus 5 minus 1 minus 1 0, 5 minus 5 0, right? It's turning out to be, A dot B is turning out to be 0. That means if A dot B is 0, A must be perpendicular to B. Therefore, this line must be perpendicular to this line. The two lines must therefore be perpendicular to each other. Two lines therefore must be perpendicular to each other. Clear? Sounds good, now? A, B, C are three non-zero vectors. Such that A cross B cross C is A cross B cross C. We need to check which of the options given is or are right. Okay? Okay, I could write this as minus C cross A cross B equals A cross B cross C. I could do this. And then I apply scalar triple product, vector triple product, C dot B into A minus C dot A into B is A dot C into B minus A dot B into C. And this plus A dot C into B and A dot C into B will get cancelled. You are then left with B dot C, that is this, B dot C into A equals A dot B into C. Right? Yes or no? See? This A dot C into B, A dot C into B will get cancelled from both sides. Now there are two possibilities. This is just a number, B dot C. A dot B is also a number. So if these are non-zero, if B dot C and A dot B are non-zero, then A could be written as scalar times C. That means then A and C will be parallel to each other. That's one possibility. If this and this are non-zero, then A could be written as this by this into C. That means a scalar times C. That means one possibility is the vector A parallel to the vector C. That's one issue. Second, if A is not parallel to C, and the equality is still holding good, if A not parallel to C, if A not parallel to C, then the only possibility is this and this must be 0. Isn't it? This must be 0 and this must be 0 if A is not parallel to C. That means B dot C must be 0 and A dot B must be 0. Which means B must be perpendicular to C and A must be perpendicular to B. Yes or no? Let's look at problem 11. Simple, na? B and C are two non-collinear vectors. See, when they say collinear, non-collinear, it's related to whether they are parallel or not. If two vectors are parallel, they say they are collinear vectors. That's what it means in vector parlance. Okay. Collinearity of two vectors actually doesn't mean they're collinear, it means they're parallel or not. That's what it means, right? B and C are two non-parallel, non-collinear vectors. That's given, problem 11. B not parallel to C. We want to find the number of solutions x, y in 0 to 10 of the equation a dot b plus c equal to 5 and a cross b cross c equals x squared minus 2x plus 7b plus sin y c. Hey, if they are non-parallel vectors, I look upon them as linearly independent vectors. They could be used as base vectors, right? That means if 3a plus 5b is xa plus yb, then x must be 3, y must be 5. I can equate the coefficients of a and b in the event they are linearly independent vectors, right? Okay, good. This is in the BC plane, right? I'll write this as a dot c into b minus a dot b into c equals x squared minus 2x plus 7b plus sin y c. So can I equate the coefficients of b and c on both sides? I could do that, right? So don't I end up getting a dot c equals x squared minus 2x plus 7? And will I not get a dot b as minus sin y? What is this? A dot b plus c. So I want to add this, I'll get a dot b plus c, 5. So if I add these two, I get a dot b plus c, isn't it? A dot b plus c equals x squared minus 2x plus 7 plus minus sin y is what I get, right? But a dot b plus c is 5. 5 equals x squared minus 2x plus 7 minus sin y. I need to solve for x and y, where x and y belong to 0 to 10. That's given. I want to find all sets of x and y's giving this. So now, can I say sin y equal to x squared minus 2x plus 2? Can I write this as x minus 1 whole squared plus 1? This is always greater than or equal to 1. This is always less than or equal to 1. What's the only possibility? Both must be equal to 1. See, this is always greater than or equal to 1. But this is always less than or equal to 1. In order that this equality occurs, the only possibility is both equal to 1. Both equal to 1 means sin y equal to 1 and x must be equal to 1. Sin y equal to 1 means y could be pi by 2, then 3 pi by 2, because see, it has to be less than 10, greater than 0, less than 10. It could be, right? Then what are the other values? Can it be 5 pi by 2? It could be 5 pi by 2. 5 pi by 2 is less than 10. And is it 3 pi by 2? It's not 3 pi by 2, because 3 pi by 2 sin y is minus 1. 3 pi by 2 is the same as minus pi by 2, but sin minus pi by 2 is minus 1. But can I not have 5 pi by 2? This is less than 10. but not more than this. 9 pi by 2 will make it greater than 10. But we need to select values of x and y not beyond this chosen interval 0 to 10. So x must be 1, y could be either pi by 2 or 5 pi by 2. If B and C were parallel, then I couldn't equate coefficients of B and C on both sides like I did, because they would be linearly dependent, right? And D is a non-zero vector perpendicular to A plus B plus C, that's given. D is perpendicular to A plus B plus C, that's given in the problem. That means what? D dot A plus B plus C is 0. That's given, because D is perpendicular to A plus B plus C. Now, the vector D is given as sin x A cross B plus cos y B cross C plus twice C cross A. That's given. We want to find the minimum value of x square plus y squared. We want to be able to find the minimum value of x square plus y squared. Obviously, given this, I want to use this. D dot A plus B plus C is 0, right? So I do a plus B plus C dot this dot A plus B plus C. If I change the order, it doesn't matter in a dot product. I could prefix it or postfix it, does not matter. Don't worry. Now A cross B dot A will be 0, A cross B dot B will be 0, ABB. A cross B dot C would be scalar triple product ABC. Scalar triple product ABC. Into sin x, right? Now, B cross C dot A would be BCA, which is the same as ABC, taken out of the bracket, right? Plus cos y. Twice. Now C cross A dot A, 0. C cross A dot C, 0. C cross A dot B would be CAB, which is the same as ABC taken out, plus 2 is 0. Yes or no? Now ABC are non-coplanar, so this is not 0. If ABC are non-coplanar, their scalar triple product cannot be 0, right? So this is non-zero, but the product is still 0. That means this must be 0, right? That means sin x plus cos y plus 2 must be 0. Yes or no? Hey, but we know that sin x is always less than or equal to minus 1. Cos y, greater than or equal to minus 1. Cos y is also greater than or equal to minus 1. That means 1 plus sin x plus 1 plus cos y is always greater than or equal to 0. 1 plus sin x is never negative. 1 plus cos y is never negative. The sum is always greater than or equal to 0. This is actually 1 plus sin x plus 1 plus cos y. This will be 0. See, this is 1 plus sin x, 1 plus cos y equal to 0. This is a non-negative number. This is also non-negative. Isn't it? 1 plus sin x can never be negative. 1 plus cos y also can never be negative. Sum of two non-negative numbers, when can that be 0? When both are 0. When both are 0. Sum of two non-negative numbers is 0 when both are 0. That means this must be 0 and this must be 0. That means sin x must be minus 1 and cos y must also be minus 1. Right? We want to find the minimum value of x square plus y square. We want to find the minimum value of x square plus y squared. Do you realize that in order that x square plus y squared is minimum, y, the minimum value is pi? Y squared, the minimum value of y squared will be pi squared. Yes or no? All other values of y squared will be greater than pi squared, because y would either be plus minus pi or plus minus 3 pi plus minus 5 pi. So their squares will always be greater than pi squared. So the minimum value of y squared is pi squared. Yes or no? Huh? Now x is like, say one of the values is minus pi by 2. The minimum x square will therefore be pi square by 4. Minimum, this is, see, x could have been again, you know, smaller than this. Minus pi by 2, minus 2 pi for example. Minus 5 pi by 2 could have been a value of x. But the minimum x square will be pi square by 4. This is minimum y squared and this is minimum x squared. This is not minimum x, but minimum x square will still be pi square by 4. Will you buy this argument from me? This is not minimum y. Y could have been minus pi, minus 3 pi, minus 5 pi, right? But the minimum y square will be pi square only, because the squares of all other values of y will be greater than pi squared. Similarly, I claim that minimum x square will be pi square by 4. So minimum x square plus y squared would be pi square plus pi square by 4. That makes it 5 pi squared by 4. So minimum x square plus y squared is 5 pi squared by 4. Problem 15. We have a vector r dot I minus 2j minus 4k equal to 0. I plus 2j minus 4k equal to 0, and r cross I plus 2j plus k equal to I minus k. We want to be able to find the value of mod r. All right. So it's as if, you know, just to make things look convenient, let me call it A, let me call it B, and let me call this vector C, for example. So it's as if r dot A is 0, right? And r cross B is C. Hey, do you realize that to bring a r dot A, if I did a cross this, then I'll get a dot r in the vector triple product? If I did a cross this equal to a cross C, then I'll get a dot r somewhere. Things might look a little better if I did that. So a cross r cross B is a cross C. Only reason I did this was because this would pop out a dot r, which will be 0. Right? So vector triple product, this is going to give me a dot B into r minus a dot r into B is a cross C. But a dot r is 0. A dot r is 0, that's given. A dot r 0. So that gives me R equal to A cross C by A dot B. A dot B is a number I could divide, right? So you would know the vector R. Mod R therefore would be mod of A cross C by mod of A dot B. You'll be able to find mod R very readily. You could even find the vector R from A dot B in the denominator and the vector A cross C in the numerator by taking the cross product of A and C. You could do that, right? Problem 16. There is an equilateral triangle and there is a circumcircle of this triangle. ABC, right? And the length of each side is L. And P is any point on the circumcircle of this triangle. P is any point on the circumcircle of this triangle. Now, we want to find magnitude of PA whole squared plus magnitude of PB, the vector PB whole squared, plus magnitude of PC whole squared, right? Tell you something. There are times you should not take cognizance of so many things that you have learned. All right, just be a little practical in an exam, because in an exam all that would matter is the answer and therefore the score, and that's all. I'm not saying don't know the subject, yet at the same time being a little test smart is always an advantage. All right, now see, if this is inquired about, that means this should not depend on where P is. You can guesstimate that like an intelligent idiot. Right? It should not depend on where P is. So what we do is, let me cause P to coincide with one of the vertices A. Then PA will be 0, PB would be L, PC would be L. So this will be 2L squared. This will be 2L squared for sure. You know what I'm saying? Why break your heads unnecessary? This has to be 2L squared. Khatam. Next problem. If you want to find it technically at home, please try this. I will not waste my time on this, but this is A, this is P, this is B position vector, this is C. All right. Then the vector PA, for example, would be position vector A minus position vector B. Mod PA squared is going to be mod of, that means A minus B dot A minus P dot A minus P. Do that for all, mod A squared plus mod B squared, and work through the usual stuff. Do that for all of them, mod PA squared, mod PB squared, B minus P, B minus P, and see what happens. That will be another 2-3 lines, but it's unnecessary because it takes so much time to write all this thing. Do this if you want to. Not recommended, but your choice. Shall we move? What you could do is, see, one of the things, I mean, you could select the origin as the circumcenter of the triangle. That might just make life a little easier, because then you'll have a term, for example here, P dot A plus B plus C, which will be 0. A plus B plus C by 3 will be the circumcenter, the centroid, etc. for an equilateral triangle. All of that would be 0. That will just mitigate the computations a little bit. X and Y are two non-collinear vectors, means non-parallel. x, y are non-parallel vectors. X and y are two non-parallel vectors. All right. And there is a triangle ABC with sides small a, small b and small c. It's given a minus b, the vector x, plus, side a minus side b minus c, the vector y, plus c minus a, x cross y. X cross y is 0. Now, x and y are non-parallel vectors. See? So, there would be a plane that they determine. This is x, this is y. Vectors x and y lie in a certain plane that they together determine if they are non-parallel. Right? And x cross y will be perpendicular to that plane. Yes or no? Will be perpendicular to the plane containing x and y. Now, x, y and x cross y therefore will be non-coplanar vectors. X, y and x cross y will be non-coplanar. If they are non-coplanar, they must be linearly independent, right? X, y and x cross y, non-coplanar or linearly independent. Linearly independent vectors could be used as base vectors, right? So now, if x, y and x cross y are linearly independent vectors, then can I not say that this must be 0, this must be 0 and this must be 0? Can that be said? If there are, isn't it? Right? So that means a minus b must be 0, b minus c must be 0, c minus a must be 0. Therefore, a equal to b equal to c. The triangle must be equilateral. The triangle must be equilateral. In problem 18, they give you a vector A, which is I plus j plus k, a vector B, which is I cap minus j cap plus k cap, right? And C is a unit vector perpendicular to A and coplanar with A and B. With A and B. Perpendicular to A but coplanar with A and B. That's given. No. See, in the same plane, if this is A, then in the same plane I could have had a vector perpendicular to A and coplanar with A. Right? C is a vector perpendicular to A and coplanar with A and B. Perpendicular to A means it will be A cross something. A cross something will always give me a vector perpendicular to A, but a vector lying in the AB plane, A cross B. A cross B cross C will always be a vector in the BC plane. So A cross B will always be a vector in the AB plane, but perpendicular to A, yes or no? Nahi kya? This is a vector perpendicular to A but lying in the AB plane. A cross B cross C is always a vector that lies in the BC plane. This will always lie in the AB plane. So this vector, so all that you need to do is evaluate this, divide by its magnitude, will give you a unit vector perpendicular to A but lying in the AB plane. Finish. Find this and divide by its magnitude will give you a unit vector perpendicular to A and lying in the AB plane. Right now? Triangle ABC P1 is any point in the plane of triangle ABC. P1 is any point in the plane of triangle ABC. O and P be the circumcenter and orthocenter of the triangle. P is the orthocenter and O is the circumcenter of the triangle. Right? O is the circumcenter of the triangle. And P1 is any point in the plane of ABC. P1 is any point in the plane of ABC. P1 could be just any point in the plane of ABC. We want to be able to find P1A plus P1B plus P1C plus PP1. We want to simplify this. Now, realize that I could choose the circumcenter as the origin and say P1 is the position vector of the point P1. I'm just going to elaborate, but you could, this was not required. What I'm doing is not required. You could have just chosen P1 a special point. Yes, absolutely. Right? But just for the heck of it, I'm going to elaborate on this problem. This point P1. So then, do you realize that this is like, say, the position vector of A was A, position vector of B was B, position vector of C was C, and say the position vector was of P was P. Clear? Then P1A is what? Final position minus initial position. A minus P1. B minus P1. C minus P1. Right? Plus P1 minus P. Yes or no? So that makes it A plus B plus C minus 2P1 minus P I hope you realize this. Minus 3P1 plus P1 minus 2P1 minus P. Now, A plus B plus C minus P. Do you realize that O, say the origin, and is also the circumcenter. Origin and also the circumcenter. The point P, the orthocenter, right? And this is also the vector P, because this is the origin, this will also be the position vector of P. The centroid will be G, and the vector OG will be A plus B plus C by 3 would be the vector OG. Position vector of the centroid OG would be A plus B plus C by 3, right? The vector OP, see, and then the centroid divides it in the ratio 2:1. Therefore, the vector OP is going to be what? 3 times OG? The vector OP will be 3 times the vector OG. Can you see that? But OP is what? The position vector of P. So, A plus B plus C minus P is 0. What you are left with is minus 2 times the position vector of P1. That means minus 2 times OP1. Position vector of P1 would be OP1. Because O is the origin, Mridul? Got me now? The shortest distance of the point 3 to 1 from a plane, there is a plane that passes through a point 1 1 1 and a perpendicular to the plane is a normal to the plane is 2i plus 3k. That's a normal to the plane, not a unit normal, just a normal to the plane. Now first of all, what's the equation of the plane? Can I say that 2 into x minus 1 plus 3 into z minus 1 equal to 0 is the equation of the plane? Bolo. Make kya? 2i plus 3k normal passing through x equal to 1, y equal to z equal to 1, and it's like, if you are too insistent, 0 into y minus 1 equal to 0. Right? 2, 0 and 3. 2, 0 and 3. Ax, by, cz. Ax, by, cz. And passing through 1, 1, 1, so I introduce a factor x minus 1, y minus 1, z minus 1. Right? So the equation of the plane is 2x plus 3z minus 5 equal to 0 is the equation of the plane. Right? And there is a point 3 to 1. There is a point 3 to 1 not lying on the plane, and I want to find the perpendicular distance of 3 to 1 from the plane. What would I do? Put x equal to 3, y equal to 2, not there, so z equal to 1 and divide by root 13. You'll get the distance from the point 3 to 1. To get this distance, 2 into 3 plus 3 into 1 minus 5 divided by root 13. 4 by root 13, therefore is the perpendicular distance. Right? Let's look at 21. All right. So in problem 21, triangle ABC with A, B and C having position vectors A, B, C, etc. Now we are drawing through A a line parallel to BC, drawing through B a line parallel to AC, and drawing through C a line parallel to AB, right? To get a triangle, say PQR is a triangle obtained out of this, where this side is parallel to this side is parallel to this side, and this side is parallel to this side, right? We want to find the centroid of triangle PQR. Hey, suppose the position vector of Q is Q. Okay? Do you realize that this is parallel to this and this is parallel to this? So AQCB is what? A parallelogram. Perfect. A parallelogram. And the vector AQ is not only equal in magnitude to the vector BC, but also parallel. The vector EQ is the same as the vector BC. Can I say this? Opposite sides of a parallelogram, they represent the same vector. What is AQ? Q minus A. Q minus A. What is BC? C minus B. Right? So Q then turns out to be A plus C minus B is the position vector of Q. Right? Similarly, exactly the same way, the position vector of B is going to be B plus C minus A, and the position vector R is going to be A plus B minus C. The centroid of triangle PQR is going to be what? R by 3 is going to be the position vector of the centroid of triangle PQR, and this you realize is A plus B plus C by 3. It coincides with the centroid of triangle ABC. Coincides with the centroid of triangle ABC. Remember this as a result. As a standard case, regular case. Yes. You're getting test smart. Good. Similar triangles. I would rather, why? I would rather use congruent triangles here, if required. There is a point P and its coordinates are 3, 2, 1 in a system of 3 non-coplanar vectors A, B and C. That means, what it really means is that if A, B, C were 3 base vectors, then in that system, the position vector of the point P would be 3A plus 2B plus C. That's what it means. Its position vector is going to be 3A plus 2B plus C in a system defined by 3 non-coplanar vectors A, B, C. This is what it means. Right? Then the coordinates of P with respect to the system A plus B plus C. So we have a system in which there are vectors A plus B plus C, A minus B plus C, system of vectors, and A plus B minus C. Let's say its coordinates are X, Y and Z are the coordinates. Then the point P is represented like this in that system. This will be equal to this. Equate coefficients of A, B and C on both sides. Equate coefficients of A, B, C and on both sides and solve for X, Y, Z. Rather, check from options. Don't solve. Check from options. Okay? So, A, B, C, D are the position vectors of the vertices of a cyclic quadrilateral. We want to find B minus A dot D minus A B cross C plus C cross D plus D cross P. Right? You know what? B minus A dot D minus A is what vector? B minus A is this vector and D minus A is this vector. If I took the dot product of these two, for example, B minus A dot D minus A. Then I'll get AB into AD into cos A. Right? Now, if this numerator was AB into AD sin A, then this will become tan. I'm preempting that. You know what I'm saying? If the numerator turned out to be AB into AD sin A, then this ratio will become tan A. What I do is, I'll perform a check. B minus A cross D minus A. Let me do a cross product, which is then positioned to give me like a sin A between these two vectors. Yes or no? A magnitude of this will give me AB into AD sin A. Yes or no? Let me see what the cross product is. Magnitude of the cross product of this. That's going to be mod of B cross D minus B cross A minus A cross D. Yes or no? Why? Because A cross A is 0. This is like a mod of B cross D plus A cross B plus D cross A. Yay! Which is what the numerator is. Do you realize that? Huh? Right? So, this cross this, mod of this cross this is actually AB into AD into sin A. Right? Therefore, the first term ABAD will get cancelled. It will simply be tan A. Hey, if it's a cyclic quadrilateral, with tan A I will only accept tan C. Why? Because this plus this is 180 degrees. Please check for yourself if this second term is tan C. Otherwise, I will not solve this problem. Right? The second term denominator would be CD into CB cos C. The numerator would be CD into CB sin C. It will be tan C. Right? And C I can write as pi minus A because it's a cyclic quadrilateral. So tan A minus tan A 0.00000.